Hey everyone, welcome back. In this video, we will start working with one of the most widely used and important Python libraries, NumPy, which makes Python such a powerful and dynamic language. NumPy, or Numerical Python, is an essential library that contains multidimensional array and matrix data structures and functions to manipulate them. This library is used for scientific computation. You'll learn more about these data structures and functions soon. But for now, let's just consider NumPy at a high level and learn more about it. NumPy's power comes from vectorization. Vectorization enables operations to be performed on multiple components of a data object, which are called arrays, at the same time, eliminating the need to loop through individual elements. This is particularly useful for data professionals because their jobs often involve working with very large quantities of data, and vectorized code save a lot of time because it computes more efficiently. Let's explore this a little more. Suppose we have list A and list B, both the same length, and we want to create a new list C that's the element-wise product of each list. In other words, we want to multiply the first element of list A by the first element of list B, then multiply the second element of list A by the second element of list B, etc. If we try to multiply lists A and B together, the computer throws an error. To perform this operation, we could write a for loop. We'd start by defining an empty list, list C, then make a range of indices to loop over, and append the product of list A and list B at each index to list C. This gets the job done, but if you're thinking, there's got to be an easier way, you're right. We can use NumPy to perform this operation as a vectorized computation. Simply convert each list to a NumPy array and multiply the two arrays together using the product operator. The results are the same, but the vectorized approach is simpler, easier to read, and faster to execute, because while loops iterate over one element at a time, vector operations compute simultaneously in a single statement. The efficiency of this might not be noticeable now, but when working with large data sets, it will be. Vectors also take up less memory space, which is another factor that becomes important when working with a lot of data. You might have noticed that when we use NumPy, we first had to import it. This is called an import statement. As we discussed earlier, an import statement uses the import keyword to load an external library, package, module, or function into your computing environment. Once you import something into your notebook and run that cell, you don't need to import it again unless you restart your notebook. When we import NumPy, we import it as NP. This is known as aliasing. Aliasing lets you assign an alternate name, or alias, by which you can refer to something. In this case, we're abbreviating NumPy to NP. If we didn't give NumPy an alias of NP, we'd have to type out NumPy here in order to access its array function. We also discussed earlier that aliasing makes the code shorter and easier to read. Note that NP is the standard alias. If you use something else, other people might get confused when reading your code. In addition to being highly useful in its own right, NumPy powers a lot of other Python libraries, like Pandas, so understanding how NumPy works will help you use these other packages. Now, we're going to continue learning about arrays and how to work with them. The array is the core data structure of NumPy. The data object itself is known as an n-dimensional array, or ND array for short. The ND array is a vector. Recall that vectors enable many operations to be performed together when the code is executed, resulting in faster runtimes that require less computer memory. You can create an array from a Python object by passing the object to the array function. Arrays are mutable, so you can change the values they contain. If I want to change this last value from a 4 to a 5, I can do that by identifying the index number. Since we're dealing with the last value, here, it's necessary to use a -1. But I can't change the size of the array without reassigning it. If I try to add a number to the end of this array, the computer throws an error. So if you want to change the size of an array, you have to reassign it. Another requirement of the array is that all of its elements be of the same data type. If I create an array with the integers 1, 2, and then a string of color red, NumPy will create an array that forces everything to the same data type. if possible. In this case, everything becomes a string, represented here by U11, meaning Unicode 11. So be careful when creating your arrays that they all contain data of the same type, or if they don't, that this is intentional and useful to what you're doing. You previously learned that calling the type function on an object will return the data type of the object. If we do that with an array, as you might expect, we get a NumPy array. We can use the dtype attribute if we want to check the data type of the contents of an array. Here, the dtype attribute indicates that this array consists of integers. As the name implies, int arrays can be multidimensional. For a one-dimensional array, NumPy takes an array-like object of length x, like a list, and creates an int array in the shape of x. A one-dimensional array is neither a row nor a column. We can use the shape attribute to confirm the shape of an array. We can also use the indim attribute to confirm the number of dimensions the array has. Data professionals will often need to confirm the shape and number of dimensions of their array. For example, if they're trying to attach it to another existing array. These methods are also commonly used to help understand what's going wrong when your code throws an error. A two-dimensional array can be created from a list of lists, where each internal list is the same length. You can think of these internal lists as individual rows, so the final array is like a table. Notice that this array has a shape of 4 rows by 2 columns and is 2 dimensions. If a two-dimensional array is a list of lists, then a three-dimensional array is a list that contains 2 of these, so a list of 2 lists of lists. This array can be thought of as 2 tables, each with 2 rows and 3 columns. Thus, it has 3 dimensions. This can go on indefinitely. Thankfully, there are ways to help simplify working with multidimensional arrays, which you'll learn about later. And unless you're doing very advanced scientific computations, you typically won't be working directly with NumPy arrays that are more than 3 dimensions. NumPy also lets us reshape an array using the reshape method. Our two-dimensional array was 4 rows and 2 columns. But what if we wanted this data to be 2 rows by 4 columns? We just plug these values into the reshape method and reassign the result back to the array2d variable. Reshaping data is a common task in data analysis, so it's important for you to be familiar with what it means and how it works. There are many other operations that can be performed with arrays, and you'll surely learn those as the need for them arises in your projects. But there are other helpful functions and methods in NumPy that you'll use regularly. These include functions to calculate things like mean and natural logarithm, and floor operation, which round numbers to the nearest lesser whole number, and ceiling operation, which round numbers to the nearest greater whole number, and many other frequently used mathematical and statistical operations. NumPy is very robust. There are so many things you can do with it that we can only briefly consider them here. As you know, NumPy powers many other useful libraries and packages. It's important that you understand the basics of NumPy because it will help you when you start working with Pandas. As you develop your skills as a data professional, you'll find yourself returning to NumPy time and time again because it's such an integral part of advanced data analysis. That's all for now. Don't forget to smash that like button, subscribe, and ring the bell to stay updated. In the next video, we will start working with Pandas. Thanks for watching, and see you there.